Our diagram?
Yeah, I saw you guys drawing it. Guess you and Bob might have to explain it later for the rest of the class. So, of course, if you have any questions, feel free to ask away. And as always, we'll begin by practice. We'll practice the phonetic alphabet this week. So this week, we're going to do pretty similar to what we did the first week here. Just the sentence using every letter, and we'll just go around the class. So I'll go first. J is Juliet.
Alpha.
Alpha.
Charlie.
Charlie.
Kilo.
Kilo. Guess we'll pass it on back to Ralph.
Delta.
Delta.
Alpha.
Alpha.
Whiskey.
Oh,
Sorry.
Yeah, not a problem.
S. Whatever my
Which we go
Sierra.
to?
Sierra. Yeah, I got one. I got a brand new one in fact.
Okay. Lima for L.
Oscar.
Oscar. Yeah. Victor.
Echo. Lost my place.
We're at M.
That's okay.
Mike, one I didn't get last time. Yeah, Mike.
Yep.
Yankees.
Yeah. Yankee. Yep.
Bravo.
Bravo. India.
G. Golf.
Golf.
Uniform.
Uniform.
We're
at S.
Oh, sorry. Where are we?
Wait for
Sphinx.
it.
Okay. Sierra.
Papa.
What's L?
Nora.
Which?
Nora.
No. November.
November.
November. X-ray.
X-ray. Perfect. Oscar.
Foxtrot.
Foxtrot. Yeah.
All right. Q.
Quebec.
Did you notice the white guy dancing?
I don't remember you.
How is that suit, by the way?
Oh, uniform.
Uniform. All right.
Alpha.
Alpha.
I had Albert.
Am I up again?
Yeah. Over on R.
R. Romeo.
Tango.
And
Zulu.
perfect. Alrighty. So good to see everybody's got most of the alphabet memorized. 2 or 3 little trouble spots there, but not a big worry. You've still got, we're only halfway through now at week 4, so you've got another 4 weeks to fully memorize the alphabet. We'll jump right into the questions then. Alright. The diode is an important part of a simple power supply. It converts AC to DC since it...
It's the second answer.
Second answer. Allows electrons to flow in only one direction from an anode to cathode.
No.
So yeah, it flows from cathode to anode. Pretty interesting here. Like a one-way valve, cathode in terms of parts has to refer to the way the current moves through it. So if it goes from the cathode to the anode, that's because the current leaves the battery cathode side, goes through the cathode side of the diode, out the anode side, and back to the anode of the battery. Cathode and anode are one of those things that quickly gets messy, and I don't really think there's a standardization depending on the part you're talking about. They seem to go back and forth. But that's the way we're moving with it. All right, a little bit simpler now. Which of the following is not amplified by an amplifier? Resistance. Yeah. Anybody gonna argue that one? Nope. That's correct. Yeah. The only way to increase resistance is to add resistive elements to a circuit, but an amplifier can increase power, voltage, or current. The increase in signal level by an amplifier is called
2.
the gain. Yeah, gain it is. Modulation is encoding one piece of information in another, like audio inside of radio. An attenuator accomplishes attenuation, and amplitude changes are voltage, not current. Amplifiers can amplify. Sorry. Two, voltage, current, and power.
Voltage, current, and power?
That's correct. Yeah, resistance and inductance both require their own separate devices. So, which of the following is not a property of an amplifier?
Distortion.
Distortion?
That's what I think, yeah.
So it's loss. Right?
Loss.
Loss being the opposite of gain, you might think that'd be a part of an amplifier, but we typically don't talk about loss of an amplifier because an amplifier that loses you signal is a very, very bad amplifier. So yeah, gain and distortion both seem pretty self-explanatory, right? Distortion is how much the signal in is not like the out, and gain is how much more signal we get out. Linearity refers to the ability of the amplifier to produce a signal that's an accurate copy of its input. So a really good linear amplifier will take one small signal and make a perfect output that's bigger. The less linear it is, the more distortion you'll get in it. So it's kind of a related term to distortion there. Zener diodes are used as
One.
1, current regulators. Voltage regulators. Voltage regulators.
Oh.
Yeah. So Zener diodes are, you have to think of them like semi-diodes. It's a bad way to describe them, but they resist backflow just like a diode does, but you can safely break past a certain point and it'll let electrons flow in the opposite direction at a particular voltage. So the cool thing with that is because it's rated at a particular voltage, you know that the back breakdown voltage is a particular voltage. So let's say it's rated 5 volts as its breakdown voltage, then you get exactly 5 volts back across it once you meet that threshold. But unlike a resistor, it doesn't offer that much resistance when it does break down. So if you use a resistor when you're trying to do a voltage regulator, you lose a bit of power there, whereas you don't with a Zener diode. Primary purpose of a Zener diode is to...
Well, that's self-explanatory. Just number 1.
Number 1, regulate or maintain a constant voltage. Yep.
Yeah.
Exactly. So yeah. So they're most used to regulate the output voltage. Until the desired voltage is reached, they will block electrons, allowing a voltage to develop. This makes them excellent voltage references. Unlike resistors, which can also act like a voltage reference, though, when they pass their breakdown voltage, they offer very low resistance, so little power is wasted.
Is there any heat as a result?
It's a little bit. So anything that passes electrons through it will heat up a small amount. Resistors obviously much more, though, because that's what they're designed to do, is resist the current. Cool. A semiconductor diode, electrons flow from
Cathode to anode.
cathode to anode?
Yes.
Cathode to anode. That's correct. Yeah, so this is the cathode anode. The cathode of the battery is where current flows from, but the cathode of any part is where the current flows into. Anode is where the current leaves in a part, and anode is where it returns in a battery. So if you imagine...
Can you do that again slower?
yeah, not a problem. So, just do a quick and
Hey,
simple
watch
there.
that circuit there, buddy.
Oh no, it's still been either. We still have...
That's a classic.
Oh yeah, absolutely. We still have all the previous week's diagrams. So
Absolutely.
if we have a battery here. Yeah. Right? And we label one positive and one negative. We remember current flow leaves the positive and returns the negative. Electron flow does the opposite. All right? So the cathode in electron flow is where it leaves. Cathode, which means this is the anode. Then we have some part, and we'll just drop in a diode to show what's going on here. It will then enter into that side. This side becomes the cathode side of the part, because that's where the current comes into it. And the anode is the other side of the part, because that's where the current flow leaves.
While you're on this nano thing here, it was on the other circuit. I was going to ask Bob. No, it's okay. Leave it there.
Okay.
Can the current flow from right to left, as well as left to right, like pass through a diode in both directions?
You were going to specifically ask Bob, or I can answer?
No, you
Okay,
can answer.
no. So a diode should only have current go through in one direction and not in the reverse.
Not in the reverse.
Not in the
Okay,
reverse.
very good.
Why are we mixing theories?
Which, sorry?
Why are we mixing theories?
Which theories?
There's 2 electron books I have. Electron books I have. One has electron flow theory, the other has current flow theory.
Current flow theory.
And they're so confusing when you try and read them together.
Yeah, so the long and the short of it is, Benjamin Franklin, when he wrote his seminal paper on a glass rod against a silk sheet, he had a 50-50 on which way the magical fluid he discovered moved, and he guessed wrong. So now we're stuck with 50 to 100 years of them using current flow, and then suddenly realizing electrons actually move the opposite direction. And so they had a really important deciding point. They were like, we can try to fix everything that we've taught for the last 50 years, or we can just accept that electrons move the other direction and talk about current flow. The math works already for current flow, so they just said, we'll do both. And now it's the most confusing field on the planet. Yeah, this was a 50-50 gone horribly wrong. But yeah, that's the reason current flow and electron flow exist.
That's a silly question, but is that why the diode's drawn that way? So it's almost like an arrow pointing which direction it's going to flow?
Exactly. Everything works on current flow. You just kind of know that electron flow happens. So current flow moves this way, but the actual diode properties of electrons let it flow the opposite direction. So our little negative electrons here, they actually flow the other direction and flow that way through the diode. But the diagram has it reversed because it always talks about current flow. Yay! Everything is confusing, isn't
Well,
it?
no, and I'm just going to. Do we have time to touch on this for a minute?
Yeah, of course.
Absolutely. Good.
Alex,
Yeah.
if you want my honest opinion, I always get confused, and like a lot of times I put a diode across a small coil to stop the back EMF, and so I hook the coil up to the correct polarities, because I'm talking about to a vehicle in a negative ground, and then I just limit the current. I put the diode one way or the other, and I look for what's taking the current, because I can't, quite honestly, I can't always remember.
Yep.
So you just write both ways, and you can see, oh, that's the right way.
Exactly. Yeah. Yep.
Just try it if you do it back.
Good catch, Alice.
That's what you're going to do.
Does the current here,
So you've got only a few
is
milliamps.
it not come through here
It does.
and then down through this way?
No, so it goes that way. So the current will flow through there, and then it will flow through there
So it's going over here to the
resistor.
resistor. And this is actually the direction in which it flows.
Yep.
Okay.
Question, which way are they going to ask it on the exam?
They're always going to be referring to it in current flow. So,
Okay, there.
yeah. Electron flow, as I said, it's one of those things that it's good to know, but most people deal in current flow unless they're curmudgeons and say, well, the electrons flow the other direction. So, Industry Canada will ask about current flow. Anything else while we're here?
No, it's good.
All right, excellent. All right, what semiconductor device glows different colors depending on chemical composition?
The number 3, the emitting diode. No.
Yep, light emitting diode.
Yeah.
All the other devices are bulbs, not semiconductors. So it doesn't matter whether or not a vacuum tube may or may not glow. They specifically say what semiconductor device. So that's the only answer that is correct.
I wish they were all like that.
Oh man, don't we all? Voltage regulation is the principal application of the Zener Diode. That's correct. Yep. LEDs make light. Vacuum diodes are great amplifiers, and junction diodes are for AC to DC, in the simplest world possible. Of course, when you're engineering, you can pick anything and make it work if you try hard enough. All right. In order for a diode to conduct, it must be forward bias. Yep, that's correct. It biases the current in the forward direction. That's all forward bias and reverse bias means. So.
Excuse me, these are your slides, aren't they?
Yep.
Okay, so the spelling mistakes are from you, not
Yes. What did I get wrong?
eh?
Which way did I get wrong?
Vacuum.
Hey, good to know. Thank you.
All right.
That's the Canadian spelling of vacuum.
On that same slide, is vacuum
back.
triodes, shouldn't it be?
Vacuum diode?
Vacuum triodes make great amplifiers,
They specifically refer to a vacuum diode.
but I've never seen a vacuum diode.
I've never seen it either, but yeah.
Okay, we'll go down. Thank you, everyone.
Alrighty. So, which component can amplify a small signal using low voltages?
Number 2.
PNP transistor? That's correct. Yep, tubes and transistors both can. Resistors and capacitors are attenuators, and a battery is not going to do anything at all for you.
Not going to help.
So, the 3 leads from a PNP transistor are named
Number 3.
gate, source, and drain. No, sorry, collector, emitter, and base.
I like that one, yeah, number 3.
Collector, emitter, and base. Yep, that's correct. So yeah, the gate, source, and drain are field effect transistors, or FETs. PNP and NPN are so-called bipolar junction transistors. And now we get in this fun field. Sorry?
The PN is positive, and the NPN is negative. Is that correct?
Sort of, yes. So the best explanation I can give for that is check out the video online. Negative and positive refer to the signs of charge that move in a particular semiconductor material. So yes, sort of, but it doesn't actually mean that the semiconductor material is positive or negative. It's just the type of charge that moves in that particular type. So.
If I could just quickly add something there.
Yeah.
When I'm working on an old radio, if it's a positive ground, it's nearly all PNP. If it's a negative ground, it's nearly all NPN.
Exactly. Yep. Here's the next thing. FETs versus PNPs or bipolar junction are kind of a holy war. Everybody likes to argue about which one's better and superior for no reason whatsoever. FETs are voltage controlled. In the simplest way to explain it, FETs are voltage controlled, and bijunction transistors are current controlled. BJTs are mostly used for amplifiers, that's your NPN and PNP, whereas FETs are mostly used for just about anything else. So when you're going to do an amplification, you're typically going to use the bipolar junction. That's the NPN or PNP. And the FETs are going to be for anything else, like when you're switching, doing a manual switch in a digital circuit, for example. Yeah, it's... The engineering behind understanding why this happens in the math is totally beyond the scope of the basic course, but they're going to ask you some of these questions, and knowing this sort of difference between the two of them is going to make a lot of the questions much simpler to understand. So, alright. If a low-level signal is placed at the input to a transistor, a higher level of signal is produced at the output lead. The effect is known as amplification. I like this week. Everybody's just like on top of every single answer. The other three, yeah, make no sense. Bipolar transistors usually have
2 leads.
2 leads.
Oh, 3 leads.
Bipolar transistor. 3 leads.
transistors have.
Minimum.
Yeah, exactly. A minimum of 2 leads.
Yep.
Yeah, not much else to be said here. It's although it's bipolar, it doesn't mean bi means 2. It just means that it has 2 different input, one in and one out. So, all right. A semiconductor is described as a general-purpose audio NPN device. This would be...
A semiconductor is described as a general-purpose audio
detector.
NPN device would need bipolar transistor.
Bipolar transistor. Yep, right on the head. Audio is a voltage differential, so we would use the BJT. The 2 basic types of bipolar transistors are...
Number 3.
NPN and PNP?
PNP.
That's correct, yep.
You said that earlier.
Varicap and Zener are diodes. NPN channel types are FETs. Remember, the channel is part of a FET. And the diode it's a diode. A triode is a vacuum tube. So, a transistor can be destroyed in a circuit by...
Excessive heat.
Yeah.
excessive heat.
Yeah.
That's correct, yeah. I might even go as far as to say that heat is the only thing that kills things in a circuit. I mean, if you put too much current or voltage, it's producing too much heat and it'll kill it inside. So, yeah, the current doesn't kill, heat does, as the old joke goes. In a bipolar transistor, the blank compares closest to the control grid of a triode vacuum tube.
The emitter.
Number 3. The base.
Base. Yep. In a bipolar transistor, the blank compares closest to the plate of a triode vacuum tube.
Try the emitter again.
Just keep trying emitter. Nope, it's the collector. So, and finally, in a bipolar transistor, the blank compares closest to the cathode of a triode vacuum.
Bipolar.
Emitter.
Emitter.
Next one is drain.
Next one is drain.
Probably, yeah.
I'm just wondering if you just did a very, very simple vacuum tube and a very simple transistor, and you can see you can see that the grid is the base, and the cathode is the emitter, and the anode is the collector. And if people can see that, then maybe could relate to that.
Okay. So, we have base,
Can't see.
right? And I think this is kind of what you're getting at, right, Jeffrey?
Yeah, although I would have done the transistor with the base in from the left, the anode at the top, and the
Just a schematic.
emitter. So it will be. Do you want me to?
Yeah, go for it.
Yeah, just redraw it. Yeah.
Yeah.
Here, I'll switch over.
Only because I would think that they would look fairly simple.
Sorry, is that the darkest pen you have? It's not coming out that well.
Here, try this one.
Oh.
That's worse, isn't it?
Oh, that's a nice
There
one.
we go.
That's a nice one. Take that one home with you when you go.
I'm gonna steal any of Glenn's markers.
So.
Oh, okay.
Okay, so this would be emitter, collector, base, and then you do a tube, which is okay, and that's a tube. So this is anode, which is this, and this one is cathode, which is that, and this one is the grid, which is that, and
Which is base.
basically the same thing.
Yep.
Okay,
Cool, yeah.
thank you very much.
No, not a problem.
That's good, yeah.
Hopefully that helps everybody out a little. So, did I skip ahead? Yeah, so you... Alright, there we go. Sorry about that. Which semiconductor device has a characteristic most similar to a vacuum tube? So, field effect transistor. Both are current operated. Cool. If you wish to reduce the current flowing in a field effect transistor, you could...
It's gotta be one, right?
I would say 3, increase the forward base
You want to
gain.
reduce the current.
If you want to reduce it, you'd
Yeah,
say
to reduce the current.
number 1,
No, I was wrong.
number 4. Wow.
Reduce the resistance.
So, yeah. The reverse bias is that it reverses the bias of the electrons in the device. So if you remember back from the video on how field effect transistors,
Didn't number 1 say that?
so let's decrease the reverse bias.
Oh, that says increase.
Yeah, grain. That's the emitter.
The emitter, yeah.
Oh, that's that emitter again.
All right.
That's in section 9.
Yep, 9.9.
I don't even know it. I remember the section. I got more yellow paint in my book than you can shake a stick at.
Yeah, it's just because they have the different like names for each of the parts on both the BJT and the FET. So, the drain of a field effect transistor corresponds to the blank of a bipolar transistor. I love how they first want you to know the bipolar, and then they're just like, how does that compare to the FET? Collector. Yep. Which two elements in a field effect transistor exhibit fairly similar characteristics? I need coffee.
Source and the drain.
Source and gate?
Drain.
Source and gate, source and drain? Source and drain. Yeah. They both pass current, they don't control it. So, although the other ones were either 1, not a part of the device, or 2, they control it. So,
Is that the one you said last week? You could use them backwards, but don't do it?
don't think I did say you could use them backwards, but I wouldn't do it, yeah. It might be possible, actually, I'm not sure.
I'm just saying, like the gate is basically like the base. You've got to think of it that way. You know, that's okay. So
Yeah, no, not a problem. Alrighty. What is one reason a triode vacuum tube might be used instead of a transistor in a circuit? As a new guy, I'd say it's the only reason, but...
Number 3.
Number 3?
Higher power.
Higher power. Yep, higher power. Vacuum tubes are designed to be used hot, so they can handle much higher power. So, comparatively per dollar and per size. A feature common in a triode tube, to triode tubes and transistors is that both
I would say number 3.
can amplify signals. Yep, they can both amplify signals.
Yeah.
So, yep. Only the third applies to transistors. Everything else specifically refers to tubes.
Tubes, yeah.
So, in a sorry?
Doesn't triode, is that not the key word to signify tubes?
It is.
It is.
Yeah. So triode is never used to refer to a semiconductor. It's always referring to tubes.
Yeah.
In a vacuum tube, the electrode that is operated with the highest positive potential is the
Number 2.
filament.
Positive potential. Yes.
Another cathode.
The plate.
Plate. Okay.
So, although the highest potential, if you were referring to it without the word positive, would technically be the cathode, that's where all of the electrons sit before they're passed across the grid to the plate. The plate has the highest positive potential because that's where all of the electrons aren't. So,
Plate and anode are the same thing.
exactly, the plate is the anode.
Yeah.
Yeah.
So is there just one plate?
Yep. So, if you look down there, right, you have at the bottom the cathode, sort of a wire, right?
I saw the K, yeah.
On that, we're going to be heating it with a heater in order to create free radical electrons that can fly around inside of a vacuum.
Absolutely.
They'll pass across to the plate, and the grid will influence them so we can increase the signal through amplification.
So the plate is being the anode
Yep.
and the grid.
Yeah, so cathode is the K down at the bottom.
Yes.
Yeah. In a vacuum tube, the electrode that is usually a cylinder of wire mesh is the
That'd be 1.
filament, the heater.
Gosh.
Grid, number 4.
Oh, no.
The grid. So if you think about the mesh, right, it's what a grid essentially is. It's just kind of like a fence. It regulates electrons from the emitter to the plate. In a vacuum tube, the element that is farthest away from the plate is the
The emitter?
That'd be 2.
so it's the heater.
Oh, yeah.
So without a heater, the emitter won't emit electrons, and because that's what causes the electrons to be emitted from the cathode, we want to keep that as far away from the plate as possible to increase the differential that we have.
In the break, I'll show some of the larger tubes. You can actually see those components and see the construction of it, so it'll make more sense then.
Yeah, absolutely, that'd be fantastic, yeah. So, in a vacuum tube, the electrode that emits electrons is the
Cathode.
cathode, yep. Alright. Often called the emitter. So,
You didn't have emitters in there again.
yeah, yeah. Well, if you want to think about it, right, the reason that you have the plate and the cathode, right?
You gotta have one to have the other, don't you?
Exactly, yeah. Well, but if you think about the bipolar transistor, right, you have the emitter and the collector. So you can think about the emitter is where the electrons come from to go to the collector, right?
Absolutely.
Perfect. What is inside the envelope of a triode tube?
Argon.
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 I used to call them vacuum tubes.
Yeah.
Yeah.
Like,
It's a vacuum.
Oh, yeah, but what's inside the envelope? That's where you're getting me off on.
So they're using the word envelope as one of those things why they're using broadside when they're talking about antennas. It's just to confuse you.
Yeah.
They're talking about the glass case.
Yeah,
So.
okay.
And can I just add one quick thing there? When you look at a new tube, you see this burnt spot that's actually shiny.
Yeah.
And that's called the Gettering spot. And what that is a little pellet of magnesium. So after they've got the vacuum, then they warm the tube up and that sort of burns any
Dissipates it?
burns any air or gas or anything that's in there to make a really good vacuum,
Oh.
and that it causes a shiny spot on the tube.
Yep.
I'll show you that at the break time, because one tube you can see all these bits, and then once you've seen it, then you can remember it. But it's very hard just with words, I'll be honest.
Yeah, yeah. I think this is very much a hands-on
Absolutely.
hobby.
Yeah, it is.
You gotta get up with a bunch of guys that are doing a project and just, fall
Absolutely.
in.
I think since getting my license is where I've learned the most, not when I was getting it. So it's definitely, once you get involved in the community, lots of the guys who've been here 20, 30, 40 years know way more than I do.
We don't have any of
50
those old guys here, do
years.
we?
Sorry?
We don't have any of those old guys here, do we?
No, it's all young guys tonight. It's weird. So, yeah, how many grids are there in a triode vacuum tube? Just one. So, even though they're using the word triode, the same with the bipolar, it doesn't mean two, it just means the triode is the three different parts of the triode.
I see.
So, yeah, the three electrodes, that is just wires, right? One plate, one emitter, one grid. Alright, in a regulated power supply, there we go, the transformer connects to an external source, which was referred to as
Input.
The input.
Yep. Everything else doesn't really make sense there. So. Yep. All right. In a regulated power supply, the blank is between the input and the rectifier.
Oh, transformer.
That's correct.
Yep.
In a regulated power supply, the blank is between the transformer and the filter.
Rectifier.
Rectifier. Yep. In a regulated power supply, the output of the rectifier is connected to the
Regulator. Oh, the filter.
Filter.
Yeah.
In a regulated power supply, the output of the filter is connected to the
Regulator. I had it backwards.
not a problem.
there.
In a regulated power supply, the blank is connected to the regulator.
Output.
There we go.
Yeah.
So, what device converts household current to 12 volts DC? It's a
Power
low-pass filter.
Number 4.
Number 4. Yeah.
That's a tough
Everything else is
That's a
wrong.
tough one.
Very, very wrong. And like on RS0232 in your face. How many you got in your house? I got like 5, right?
Have you ever seen a catalytic converter?
Not up close, no.
Oh, yeah.
I know my car has one, but
Yeah, that's where they are.
I go
yeah,
over
everything
with
else is just now. So I wish all the questions are like that, right? Alright, which of these usually needs a high current capacity power supply?
Transceiver.
Yeah.
Yep.
Transceiver.
So the transceiver requires power to excite the antenna. A receiver can operate without power, but most will use something like AA batteries in order to power a speaker. And a switch and an SWR meter are typically passive. They typically require no extra power. So, what may cause a buzzing or hum in the signal of an AC powered transmitter?
Number
I would
1.
say number 3.
3.
A valid filter capacitor in the transmitter's power supply? Yep. So, yeah, it filters. So, yeah, that's exactly what would
How
happen.
does a filter go bad? Or is it a manufacturing issue? Or
So, it could be a manufacturing issue. The number one way I'd imagine is because a lot of them will use a electrolytic capacitor. If that starts to dry out,
Yeah.
or if it explodes, worst case scenario, then you basically have no capacitance there and you will get no filtering.
Especially if the radio wasn't in use for a long time. Is that,
Exactly, yeah. Electrolytics can dry out over time.
or
Yeah,
a power supply or
absolutely.
whatever.
Yeah.
Isn't there a correlation though on heat somewhere in there? Because when it dries out, the heat.
Yeah.
It's the heat's a killer, correct?
Well, so not always. Electrolytic capacitors are submerged in a fluid inside, and if that fluid it slowly evaporates,
Leaks.
exactly.
Yeah.
So if some power supplies may be poorly designed and put electrolytic capacitors near things like heat dissipators, like the fins that you see typically on devices that produce a lot of heat, that you'll typically know very quickly if it's going to cause a lot of problem. But just over long periods of time of in use, an electrolytic capacitor can eventually break down and die out. So, yeah. Any other questions? Cool. A power supply is to supply DC at 12 volts at 5 amps. The power transformer should be rated higher than
60 watts. 60 watts, yeah.
60 watts. Yep.
Yeah.
12 times 5.
Oh, yeah.
So your transformer would have to be rated higher than 60 watts. To convert AC to pulsating DC, you could use a
Capacitor.
capacitor,
No, diode.
diode. Yeah. So if we remember what it does, you have that sort of sinusoidal wave that you get in AC, right? When we use a diode, we just kind of get bump, flat, bump, flat, bump, flat, as it cuts off all of the negative side. It's technically DC, but I wouldn't use that as an actual power supply for anything. It's pretty bad. All right. You have a very loud, low-frequency hum appearing on your transmission. In what part of the transmitter would you first look for trouble?
The power supply.
Power amplifier circuit.
The power supply.
That's fine.
Yep.
So,
What's the difference between that and the circuit?
so an amplifier would be taking the power that you have inside there and amplifying it to get more power out. Typically, this will happen after your system is done with it.
Hence the word amplify, yeah.
Exactly. But the power supply is where you're initially going to get that DC power or AC power, whichever you need for your particular device. So yeah, bad power source is a common point for hams. The action of changing alternating current to direct current is called
Number 3.
transformation,
Is that right? No.
Number 1.
No, number 1.
rectification, Yeah, rectification. So, if alternating current is applied to the anode of a diode, what would you expect to see at the cathode?
Can we go back?
Yeah, I guess I'll just get the answer to this one first.
Hold on. Let me see this.
Pulsating direct current? Yeah, that's correct. Which did you want to go back to there?
Well, okay, that well, you're saying the power supply. Very loud, or very loud, low frequency hum. Appearing in the transmitter, or the transmission.
Mm-hmm.
Yeah, okay, my mistake.
No, not a problem. Yeah, so the loud low hum, by the way, is the 60 hertz that our power sub works at here.
It
If that
wasn't
60
yellow.
hertz signal was leaking
Yeah,
into the...
I had it there too, I know.
Was it yellow?
Alright, then.
Look at what?
Alternating So we got this one, pulsating direct current.
Yes.
Yeah, basically, you just get the positive side of the wave with 0 voltage in between where the negative used to be. It's not good DC, but it's technically not AC, so it's DC. Again, never feed this into a DC circuit just through a diode. It's not really good DC. So you want a nice, clean, flat signal. How is a voltmeter usually connected to a circuit under test? It's in quadrature.
In phase with the current.
In phase with the current?
Parallel.
Yeah, in parallel with the current? Yeah,
Parallel.
it's in parallel.
Yeah.
So, so it has to be essentially across the circuit, right? If you imagine the circuit there, then you connect it across 2 different points, a particular device, and it measures the voltage difference on that device. So, how is an ammeter usually connected in a circuit under test?
It's
In
the
series.
same theory, going over the top, it's a series, yeah.
Well, not exactly.
You break the line, put it in the line.
So, just a quick drawing, just to recap. We'll go back to our favorite circuit ever, the 1 resistor, 1 battery circuit. So if you imagine you want to find the voltage, right? The voltage is developed across different devices. So you can, let's say for example, connect from here to our voltage meter. And that'll tell us what the voltage is across that particular resistor, right? But if we want to check out what the current is in the circuit, right? The current is consistent across the circuit. So what we actually have to do is we have to separate the circuit. And we actually have to splice into the circuit to find out what the current is going through it, right? So that's why this is in series, whereas this is in parallel.
Okay.
All right. Which of the following meters would you use to measure the power supply current drawn by a small handheld transistorized receiver?
I would say number 3.
A DC ammeter? Yeah, that's correct. So a receiver only needs a little bit of power to amplify a signal for a speaker, so it's usually just a DC power source, like a couple of batteries. It's kind of a weird way to word it, but yeah, technically correct. When measuring current drawn from a DC power supply, is it true to say that the meter will act in a circuit as... Sorry, it is true to say that a meter will act in circuit as...
I'd say 1. Is that right? Next to
Low value resistance.
Number 3, yeah.
Number 3? Yeah.
Low value resistance.
Mm-hmm.
Yep.
Okay.
Any meter will provide a resistance, but typically a very small one. So, when measuring the current drawn by a receiver from a power supply, the current meter should be placed
In series with the receiver power pads. Power leads.
in series with one of the receiver power leads.
Yes.
Yeah. So, You can't connect in series to both leads. That doesn't make any sense whatsoever. That would be in parallel, or it becomes the entire part of the circuit. So, and ammeters must be connected in series.
Oh yeah.
Oh, no, this one.
Oh yeah, absolutely. Sorry.
All right, sorry this one's a little bit small, but quite a long question. In order to install any radio apparatus to be used specifically for receiving and automatically retransmitting radio telephone communications within the same frequency band, a radio amateur must hold an amateur radio operator certificate with a minimum of... I'll read the bottom ones just in case everybody can't see it. Basic with advanced qualifications, basic with Morse code qualifications, basic qualification, basic and honors qualification.
That's the one.
Basic and honors?
Yes.
I think it's basic and advanced.
Basic and advanced? Yeah.
Yeah.
Oh,
So the key is that it's on the same band, right? With the same frequency band.
Good.
Yeah, sorry, but repeaters on the same band are not allowed by the basic qualification. You can do cross-band repeater, right? That is like from, let's say, 2 meters into 440, for example. That's a cross-band. You can do that with a basic, but you can't do the same band. And
if you get honors with your basic, does that not give you the privilege?
no.
It doesn't.
The only thing honors gets you is HF privileges. That's below 30 megahertz,
Yeah.
right? And you can transmit down there with the with the honors, but not enough theory behind it to be able to do same band repeaters.
With the exception of digipeating, right?
Was I don't think so. Well, digipeating is onto the internet, isn't it?
No.
Okay.
It's an IB.
All right, I'm gonna have to check that one. I'm pretty sure you can't do same band transmission retransmission with basic. Okay, we'll have to look that one up, but for now, you guys don't have to worry about that. The main thing is just,
It's a long ways down the road.
Yeah.
yeah, well, it'll be in the digital, so I guess when we go through the digital and the basic course, we'll find out whether or not you can.
Yep.
But, all right. What kind of amateur station automatically retransmits the signal of another station? Sorry, of other stations.
Number 3.
Number 3, repeater station. Yep. Space stations, love them. I have like 3. How many you guys got, right?
6.
6, wow. Got to talk sometime. All right. All amateur stations, regardless of the mode of transmission used, must be equipped with a DC power meter, an overmodulation indicating device, a dummy antenna, a reliable means of determining the operating radio frequency.
Yeah, I like that one.
I would say number 4.
Number 4, yeah, all right. Yeah, that's correct. Broadcasting on non-amateur frequencies is illegal, so if you can't tell where you're broadcasting, that is also illegal.
Yeah.
So,
Don't talk.
yeah, exactly, yeah. If you're not sure that you can say what you can say, don't say it. What is one way to shorten transmitter tune-up time on the air to cut down on interference?
Transmit on the dummy load.
Transmit on the dummy load. That is correct.
Yeah.
Yep. This is this is also made much easier with an antenna switch. So rather than having to unscrew your antenna from it, attach the dummy load, tune up, yeah, we're okay, and then unscrew and screw back. You just click, good, click. Much simpler.
Or you get an automatic tuner.
Yeah, or an automatic tuner. Yeah, exactly.
That's
So.
for me, you know.
Go hang on the roll.
Oh, automatic tuners are great. You push the button here, click, 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 and you're like, oh, it's done, and then you just go for it. But which of the following describes full break-in telegraphy QSK? Oh man.
QSK. I thought we were going to do Q codes.
They always sneak back in there.
I wrote those suckers down 3 times again the other day, actually. And I cannot remember the damn one.
Anyone brave enough to take a guess?
Intelligibility of the signal.
QSK?
Yeah.
Fair enough, yeah. But we need to know which one of those.
Breaking into 3.
Number 3. Incoming signals are received between transmitted Morse code dots and dashes.
I like it.
It's good, because it's correct.
Yep.
Yeah, I couldn't have made this more confusing if I'd tried.
Alright.
This question...
Go back and explain what we're looking at again.
Okay. So, which of the following describes full break-in telegraphy? So, when they're talking about telegraphy, they're talking about Morse code.
Oh.
That's the first thing. So, this question is best answered by removing all of the ones that don't make any sense. So, we'll start at the top. An operator must activate a manual send-receive switch before and after every transmission. Yeah, exactly, that doesn't make any sense.
No.
Next one, breaking stations send the Morse code ~sign BK. Okay, that one sounds plausible. BK is sometimes used to break into a conversation when you did it, so we'll skip that one for right now. Incoming signals are received between transmitted Morse code dots and dashes. This again kind of comes back to what we're talking about, and which of the following describes break-in telegraphy? So we're kind of dealing with break-in telegraphy. This one's a possible one. We'll skip to the fourth. Automatic keys are used to send and receive Morse code instead of hand keys. No, that's out of game, right? So we have to think about, in English, what exactly they're asking. Which of the following describes full break-in telegraphy, right? So we're specifically, which of these things would describe what you're doing when you're doing a break-in, right?
Well, dots and dashes can be taken in between the transmitted.
Exactly. So incoming signals are received between transmitted Morse code dots and dashes. So when somebody's trying to break into a conversation, you'll hear dots and dashes between when you send and the other person sends that aren't a part of your conversation. So, again, this is one of those ones they made it absolutely confusing. The answer makes no sense whatsoever. It's not clear cut, but
What are they sending?
Morse code. So I'm not
What
sure.
are they sending in Morse code when they're sending something to break in?
Typically BK, yeah.
And so,
Yeah.
We can
More
do the
confusing.
same thing at voice with box.
Okay, yeah. Yeah, you could. It's one of those questions. Just pray you don't get it on your test, I guess.
Yeah.
You can memorize it.
Or just remember it and know that it's going to be there.
I think we're only up to like 5 or 6 of those questions so far that you just kind of have to know the answer to. And I think they put them on there specifically so you can't get perfect. But that's the conspiracy theorist in me.
Yeah.
Yeah.
You know,
All right.
What I was reading one of the older ham books, just for enjoyment, like pleasure reading, but staying on subject.
Mm-hmm.
Back in the day, a pass was 60, and honors was 75.
Mm-hmm.
Now I have an understanding that a pass today is 70, and honors is 80.
That's correct.
What happened?
So the main reason for that is you can get a copy of the full test at any time. All of the questions can be downloaded digitally. So they felt that increasing it was kind of the right thing to do because you could theoretically memorize all of the questions and answers and go through the test as many times as you wanted. It's a terrible reason, and it's mostly bureaucracy and politics, but that's the best explanation I've got out of anybody as to why it was increased.
I see no difference. There's no relevance between 75 and 80.
10 questions could be a lot.
You know, when I was in high school, I was basically a C+ student. If I got 64, that was great. You know what I mean?
Yeah.
So I thought 60 was a pass and 75 was the.
Yeah, no. And unfortunately, they could pretty much set it wherever. I guess the easy way to make you feel better, as far as I know, one of my friends is going to do brain surgery. He wants to become a brain surgeon. Pass in their class is 90%. So, because the way they describe that is, would you want a brain surgeon working on you who only got 50 on the final exam, right? So, I mean, you can set a pass rate wherever you want and kind of go, okay, well, what makes sense? So, but, yeah.
Well, you don't be half a brain.
Yeah, exactly, yeah.
Yeah.
All right, does the hippocampus connect to that? I don't know. All right. Why is it a good idea to have a way to operate your amateur station without using commercial AC power lines?
Number one.
Number one, so you may provide communications in an emergency.
No.
Arguers? Nope. That's because it's correct.
Straightforward.
So, probably could have guessed that one exactly. What is the most important accessory to have for a handheld radio in an emergency?
I'd say
Several sets of charged batteries?
charge batteries.
It's the most important.
Yup, I goofed here. I was running the net. I'm not sure whoever was listening in, but there was one night I was running the net and then poof, I was gone.
Battery's gone.
And I have no charging cable or anything, so it's always good to have an extra battery on hand.
And there was someone driving around trying to find you.
Mm-hmm. There was somebody driving around.
Yeah.
May or may not have decided to send his phone number out over the repeater, but yeah, no, it's all a good time. But yeah, now I've got batteries and I can back it up. But don't be like me. Learn from my mistakes. All right, a low-pass filter in an HF station is most effective when connected.
I'd say number 3.
Number 3, as close as possible to the transceiver output.
That's the one I chose.
Good, because that's perfect. Right on the money. Yep, just filter the supply hum as soon as possible, right? So you want to get rid of any of those frequencies you're not going to be using. If you remember, a low-pass filter passes low frequencies, blocks high frequencies. So if you're going to be blocking any frequency, just do it as soon as possible. No reason to put it down towards the antenna. So that's about the right place to put it. A low-pass filter in an HF station is most effective when connected to... Oh, geez, this because it has different answers. Okay. We all know the answer is now number 3.
Oh, I think it's 3.
Sorry, I saw the same question and was like, did we just duplicate it? No. No.
Hey, possible linear to an amplifier input.
output.
No.
It's the output. Right? So, way to just simply remember this.
Okay. Yeah.
A linear amplifier is considered to be the end of your transmitter, right? So if you have an amplifier, the end of that constitutes kind of where your transmitter is, right? So then again, you want to put it at the end of the transmitter, which is the end of the linear amplifier. So, in designing an HF station, which component would you use to reduce the effect of harmonic radiation?
I would say number 3.
Number 3, low-pass filter.
Yes.
That's correct. Yeah, exactly. An SWR bridge is another just name for SWR meter. So, do you guys want to take a break?
Sure.
Okay. What time is it? As soon as we get the camera up and running.
All right.
Perfect. All right, so welcome back. Hope everybody had fun at the table, learning and talking and discussing. All right, to start us off, which component of an HF station is most useful for determining the effectiveness of an antenna system? Let's get that out of the way.
SWR bridge.
Yep.
3.
Yeah, SWR bridge. Feel free to just shout it out. So, yep, this shows how much power you're getting to the antenna, and the actual power into the antenna is what constitutes effectiveness. So, of the components in an HF station, which component would normally be connected closest to the antenna tuner, and dummy load?
Better be the antenna switch.
That's exactly it. Yep. So the antenna switch. If you got a bunch of antennas, that's probably the switch. Pretty handy to have, so you don't have to unscrew and screw on each of the antennas every time.
That one where you go click, click?
Exactly, yeah. Yeah. Actually, for the guys who are hams here, who has an antenna switch? All of them? Yep. All right.
And spares.
And spares. Yeah, they're really, really fancy. So next question. Does your antenna switch have a ground, or do you have like a switch that'll manually set it to ground for lightning strikes?
Yes.
Yes?
Automatically goes to ground.
Perfect.
Yeah, I do the same thing, just switch it off.
Yeah, exactly.
Mine's
Perfect.
actually underground in the basement, so it doesn't matter.
Oh, okay.
No.
Alrighty, moving on. Okay, I probably shouldn't have clicked next, but of the components in an HF station, which component would be used to match impedance between the transceiver and antenna?
Oh, I would say number 1.
SWR bridge?
Impedance.
Oh, sorry, yeah.
Impedance.
Yes.
Mm-hmm.
Yeah, number 2. Number 2.
The tuner.
Yeah.
So the SWR bridge will tell you about the standing wave in it, but it won't match it up for you, so.
That's what I meant to say.
Not mandatory, but handy. In an HF station, the antenna tuner is usually used for matching the transceiver with...
Well, what? First of all, you better help me out and tell me what a mono band Yagi type antenna is.
Well, if you break it down...
Yagi, you know, the one that's a folding one, yeah.
Yeah, well, the Yagi antenna's got the 3 different elements on it, right?
Yeah.
Parasitic, reflector, director.
Right.
All right, so the monoband would just be that it only works on one band.
Oh,
So
okay.
maybe like 20 meters or 10 meters, but it won't work on multiple.
Okay. I think number 1 is the answer to this one.
Below, yep. So it's below.
Yeah,
Most antennas are operating below. Really long bands can become tricky for antennas. The longer the band, the more antenna you need. The more cable you have to spend, the more money it costs. So if you can feel like you want to get away with it, you can have a worse performing antenna with less cable and material in it. So it's a great reason to have an antenna tuner for those.
I know, see, you don't have very many questions on shortwave, and there's not very much information.
Shortwave in there?
Yeah.
Well, we don't typically use shortwave in amateur radio. So,
No?
no.
We use the amateur bands, not the shortwave bands. Although some people consider the amateur bands part of shortwave.
Well, I had a wonderful conversation. Maybe we talk about this for a minute at the meeting, the club meeting at Whitecliff, with Gerard and Joe. Gerard's got an old 19 radio, and he talks all around the world on shortwave. He says that's part of amateur band.
Some people consider shortwave the amateur part of shortwave bands, and technically it is.
Yeah.
But mostly shortwave is your listening, your broadcast station, stuff like that.
Yeah.
That's why there's no questions on it.
Okay, that's all right. That just.
Am I wrong? Is that right?
No,
That's about right, yeah.
Yeah. Okay. Very good.
Alrighty. So next up, if an amateur digital radio in an amateur digital radio system, the blank interfaces with the computer. Yeah, this question.
I'd say number 1.
Transceiver?
I like power supply.
See, that's exactly what I thought too. They want the input-output.
Oh, okay.
Is it?
Wrong first time.
I mean, I guess you could call it the input-output, like an I/O port on a computer. That's ridiculous. But that's what they want. Yeah, sorry.
I just want to look at it for just half a second.
Of course.
That's one you should memorize. Yeah.
What you're saying is that's your software program, your TV, your screen on the computer and stuff going into the.
Well, so what they're actually talking about here is like a serial port or a USB port or the sound card I/O. That's specifically what we're talking about.
I can see USB working with that. Yeah.
Yeah, so they're talking about that as the input-output on the computer. The terminology they use in the digital section makes me want to slap somebody, but we'll go through it and you'll see why. So they call it the input and output. All right. In an amateur digital radio system, the modem is connected to the
input output.
Computer.
Oh yeah. Well, yeah. Okay.
So again,
This is built in, of course.
and exactly right. So many people use digital modems these days. I don't think anybody here who does digital work actually has a digital modem that they use for their radio system. They use a software.
Some of the new radios have them built right in.
Exactly.
Just USB, and you don't even need the interface anymore.
Yeah, so my radio has a built-in modem inside it. A lot of people will use a soft modem, so a program that does it and sends it out via the sound card. So the digital terminology using is kind of dated here, but it's also not very technical. Anyway, in an amateur digital radio system, the transceiver is connected to the modem. Yep. So in order for the transceiver to actually send out any sort of signal, you have to take the digital signal. Yeah, okay, I didn't have a thing. So you have to take the digital signal, modulate it into sound, and then send the sound into the transceiver so that you're transmitting sound on the radio. All right. In an amateur digital radio system, the audio connections of the modem/sound card modem are connected to the
Is that one of those input-output trick questions?
Say number 1.
transceiver.
Yeah.
They bring up the input-output once and then they never refer to it again. It's entirely
Amateur radio, digital radio system,
Audio
audio
connections
connections,
of the
modem, sound card modem are connected to the
transceiver.
transceiver. Well, you could go input output there too, could you not?
That's what it's showing.
Yeah,
that's
you
what-
could. So technically the input-output is a part of the computer, so the computer connects to the input-output, which connects to the modem, which connects to the transceiver. But the question is very vague. Again, it says that the modem/sound card modem are connected to the... Again, I want to slap somebody for all the digital questions. All right, in an amateur digital radio system, the modem function is often performed by the computer. Yes, but
Which part of it?
exactly, yeah.
Serial port.
Well, you got to put your information in, right? Radio system modem function.
They're going to say she compared it to
It's an incomplete
serial
sentence.
port.
Yeah,
Exactly.
it should be.
Keyboard?
It should read what component
Of a
of
computer.
a computer is used to perform the modem function.
Yeah. So the answer is sound card.
Sound card.
Yeah. The only way to figure this question out is which ones can it be? It can't be the serial port because that's just how data leaves the computer. A scanner doesn't make any sense because there's no scanner. I mean, maybe like I want to see somebody using one of the scanners for like text documents. That would be hilarious. And keyboard, no. Keyboard does
You
not.
could use the serial port for input too.
Well, we use
Exactly,
serial port
right?
to connect the modems.
Yeah.
It's not a
Modulating.
very question. Slap them for me too.
Yeah, exactly. Anybody who knows computers in this sort of system is like, well, no. So, all right, we're finally past that. Those are the only questions on the digital system. But a mismatched antenna or transmission line may present an incorrect load to the transmitter. The result may be 3.
Yep, full power not transferred to the antenna.
That is correct. Yep. This came up last week. Who remembered it? This was actually in last week's questions.
Me.
So. Oh, perfect. Excellent. Yeah. So that's some of the interesting things. Some of the questions overlap different sections. So actually, if we go back, you can see section 7.8, which was last week. Section 11.11. One result of a slight mismatch between the power amplifier of a transmitter and the antenna would be
3.
reduced antenna modulation.
Same.
Or radiation. Yep. Less power, less radiation.
Yeah.
The input power to the final stage of your transmitter is 200 watts, and the output is 125 watts. What happened to the remaining power?
Dissipated in heat.
Yeah.
That's exactly it. Yep.
Entropy.
So you can't just lose power; it has to go somewhere. So now it's heat. If you remember the laws of conservation of energy. So, all right. What may happen if a single sideband transmitter is operated with the microphone gain set too high?
I would say number 3. Let me see.
Splatter.
What does splatter mean again?
Very good, Jeffrey.
So splatter, from the loosest definition, essentially means you're operating outside of the particularly allowed channel,
Band.
right? Well, not particularly
they call
band.
that?
Which what?
Off band, if it's say 125.76 or something, you could be just a little off that. Is that not?
So that's another thing that could happen, but what they're talking about with splatter is more, in VHF you operate in channelized mode, right? So as you go around you have to tune in, particularly, I think it's, forgive me if I'm wrong, but I think it's 0.05 megahertz are the channel distributions in, for example, the 2 meter band?
Just points, isn't it 6?
No, 0.6 is a repeater offset.
Oh, okay, yes.
But anyway, so in VHF, they're typically channelized operations. So as you scan around, you can't arbitrarily tune to any frequency, but instead you have to like this channel, this channel, this channel. Splatter is where your particular transmission goes into somebody else's channel, right? And so that you're splattering your signal all over them is kind of the way to think about it.
If you go back to the old CB days, it was very common. You get someone down in Kuala Lumpur or something that's putting out 1,000 watts, and he's taking up 2 or 3 channels.
Yeah.
Exactly, yeah.
Oh,
so
I see.
that's splatter, yeah.
Okay. He's encroaching.
It's called
Exactly.
cross channel, right? CB.
Yeah.
And other things.
And other things.
Yeah.
Nasty.
Yeah. So yeah, if you remember, single sideband is a type of frequency modulation. There's only really 2, AM or FM. Single sideband is just one particular type of FM, like narrow FM or wideband FM.
Yeah.
If you have too much modulation, it uses too much frequency and it jumps outside of that particular channel set. So, how should the microphone gain control be adjusted on a single sideband phone transmitter?
Number 1, I think.
Slight movement of the ALC meter or modulation peaks.
Yeah.
That's correct. Yeah. So the automatic level control meter is extremely handy. The best I could come up with for this slide. Yeah, so what they're talking about, typically an ALC meter won't just kick up a little bit, but you'll have like a green section, a little yellow section, then a red section, kind of almost like you do on audio output. And what they're kind of talking about is that it should only kick into the green. It shouldn't go past that where you're over-modulating. But that's what they're talking about. What can you do if you're told your FM, handheld, or mobile transceiver is over-deviating? Sorry. Let the transceiver cool off.
I would say number 3.
Talk farther away from the microphone. That's correct. Yeah. So, yeah, or turn down the gain is another thing you can do. So.
Taking 4.
Which? Talk louder into the microphone?
Yeah. Yeah, makes sense.
Can you hear me now? All right. Nice long question for us. Here we go. You're transmitting FM on the 2 meter band. Several stations advise you that your transmission is loud and distorted. A quick check with a frequency counter tells you that your transmitter is on the proper frequency. Which of the following is the most probable cause of the distortion? I'll read the answers for you because they're pretty tiny. The repeater is reversing your sidebands. the frequency counter is giving an incorrect reading, and you are indeed off frequency. The frequency deviation of your transmitter is set too high. The power supply output voltage is too low.
Frequency deviation of your transmitter is set too high.
Bingo.
Yeah.
Yeah. So yeah, when you're using FM or single sideband, double check that you're not overmodulating, so that you don't have the gain too high, you're not talking too close to the microphone, so that your microphone gain isn't set too high. Just a couple quick checks you should do. What do many amateurs use to help form good Morse code characters?
A keyboard.
Yep.
I like that one, off-on switch.
Yeah, key operated. Yeah. So it's an electronic keyer.
Yeah.
So this is the double PAL kind of keyer. So when you want to do a dot, it does dit. When you do the dots, dot 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 dot, or dash 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 dash. So you don't actually have to like hold it for the 3 seconds or the 1 second, depending. Any comments from the?
No, we played with all that last week.
Oh, okay, perfect. All right.
That was fun.
Yeah.
It was, yeah, it was good. I like that.
So where would you connect a microphone for voice operation?
I would say number 1.
It's the power supply. So it's a transceiver, of course. Yeah. Yep, the power supply. It is the correct input. It's not. Don't connect your. No. What might a dummy antenna? Sorry. Why might a dummy antenna get warm when in use?
RF energy into heat.
Exactly.
Yeah.
So, why would it get warm? Because there's too much power into it. Why is there too much power? Because you're transmitting a signal into it. So.
Again.
Yeah, there we go. All right. What is the circuit called which causes the transmitter to automatically transmit when operator speaks into his microphone?
BOX.
BOX. Yep.
BOX.
Do you remember what it stands for?
Voice operated transmit.
Voice operated.
Exchange.
Okay,
I hate when they do this. They're like, oh, it's exchange, so it's extreme, so we can use the X as opposed to an E. But yeah, voice operated exchange is what that acronym means. All right. What is the reason for using a properly adjusted speech processor with a single sideband phone transmitter? They really want you to know this sort of stuff.
Yeah, I hope it's on the ground.
Should be.
I'm thinking it reduces the unwanted noise in the pickup from the microphone. No,
Yeah.
We're back to signal
Intelligibility.
Thank you.
Yep, not a problem. Yep.
Alex, excuse me. When I first got my new transceiver, Bob very kindly was the recipient, and we just kept doing tests until we got that right. And really, that's the only way. You have a buddy that's that you can communicate with. So I'm going to try this, Bob. Yeah, okay. No, that's too much. And then you get it right.
Yeah, it's pretty true. You'll notice the first time you ever try to get on a repeater or something like that, you'll transmit and you'll be like, all right, if a single sideband phone transmitter is 100% modulated, what will a speech processor do to the transmitter's power?
Number 1.
Number 1.
Will increase the output peak envelope power.
There's no.
Wrong, right?
Nothing to.
Yeah, if it's 100% modulated.
Yeah.
Yeah, so only AM modulation affects PEP, right? Peak envelope power. Single sideband is FM, so it doesn't.
Throw that back one.
Of course.
Transmitter power. Nothing to do. Okay, very good.
Yeah.
Okay.
Which of the following components could be used as a dynamic microphone?
Light speaker.
Yeah. So remember, a microphone is a speaker in reverse, and speakers are microphones in reverse. Generally. It's like generators and motors. The exact same thing, it's just whether or not you attach the power or you attach a listening device that converts it from the power produced. Anyway. We all understand? Moving on. Alright. In an AX.25 packet radio operation, what equipment connects to a terminal node controller?
I would say number 4.
A transceiver and a modem?
I was thinking number 2, the DTFM microphone monitor transceiver.
Nothing? No, okay.
No idea.
Yeah, so it's a transceiver, a computer, and possibly a GPS system.
Oh.
So when they're talking AX25 packet radio, they're typically talking APRS. It doesn't have to be, but they typically are. So the GPS system, yeah. A TNC is just a device that that's spell check, and I don't know what it was supposed to be. But it should wrap the data in AX25 and then send it out for modulation to your radio as sound. So you just send it into it. Which, sorry?
Palates? Is that how you
That is, nah, you have no idea what that is. Sorry, what?
It's palatoxins. That's how you say it.
It's just an,
That's, I don't know what the word is. I got in there by mistake. But yeah, so it just basically takes the input data, right? The actual like digital data, like numbers, letters, characters that would normally be in binary. It wraps that in AX.25 and then takes that and modulates it as sound so you can send that off to your radio. So it's kind of like a 2-in-1 process. I could argue that answer, but I won't. The real problem is that computer is not as cut and dry as it used to be. Again, my little handheld radio has a computer in it that does all of the TNC and stuff like that, so technically I don't have to connect anything to it. It automatically will do the computer and possibly a GPS system. It's all built into mine. But again, it's just because electronics are getting smaller and smaller. So, how could you best keep unauthorized persons from using your amateur station at home?
take it with you to work.
True. True. Put a danger high voltage sign on it. Restricted personnel only.
Number three.
Number 3, use a key operated on off switch in the main parcel line. Yep. That would work. I'm sure you could come up with like 10, 15, 20 other ways you could keep unauthorized people from using your stuff.
Make them all take this course.
Yes, absolutely. And then everybody's authorized. If everybody in the world had a ham license, we would never have to worry. All right, here's another one. How would you best keep unauthorized persons from using a mobile amateur station in your car?
Close your door and lock
Number
it.
3.
Number 3, disconnect the microphone when you're not using it. Yeah. Again, that's another. You can come up with lots and lots of ways. Just make sure you take
How
some.
many people do that?
I don't think I've ever been like, hey, I should just take the like microphone and disconnect it and then like stick it in my pocket.
I think sometimes they have a high expectation that everyone wants to run amateur radio. You know, it's like people, when I got vanity plates, people say you shouldn't get vanity plates, people will steal your radios. No, people are going to go around and steal your cell phone, not your radio.
Exactly. Though actually, I will admit, so 2 things here. 1, make sure you're doing this if you have kids. Kids love to play around with things that they really shouldn't and then get on the bands and get you in a lot of trouble, especially if they do it when you're not in the house. 2nd, I was in Quebec and took my little handheld with me and left it in the hotel room and they mysteriously couldn't find it and didn't know who had it and it was just missing. And it has my call sign in it, so if it ever comes on APRS, I'll know exactly where it was turned on. But, yep. So, people do steal them and sell them, but yeah.
What were you doing in a hotel room in Quebec?
I wasn't there.
Oh, this is getting worse. Next question.
Next one now.
Continue next week.
Next question.
All right, next question. We'll skip it. All right. Approximately which frequency range can most humans hear?
Number 1.
Number 1.
20 to 2,000? 20,000, sorry? Yep.
Yeah.
What kind of SWR reading may mean poor electrical contact? What kind of an SWR reading may mean poor electrical contact between parts of an antenna system?
A jumpy reading?
Yep.
Jumpy reading. Yep. Yeah, okay, so for this questions, it reads like the author's never actually seen an SWR meter before. A negative reading, you can't get a negative reading on an SWR meter. At least I don't think so. Anyone ever seen a negative reading? No? No reading at all. Typically, they're analog with like 2 little bars. Cool. And yeah, we just have too much power, not an antenna. All right, what does an antenna tuner do? All these questions are so open-ended.
Tunes the antenna.
Number 1, yeah.
It matches the transceiver to a mismatched antenna system? Yep, that's about right. Yeah, that's the short answer. What would you use to connect a coaxial cable of 50 ohm impedance to an antenna of 17 ohms impedance?
Didn't match into it. That's a really good way of doing that one.
Yeah.
Yeah, like an antenna tuner? That's
Yeah.
what it
Yeah.
Oh. All right, that's it. We're done.
What?
Yeah, short week this
No,
week.
it's only 7:30.
I know.
Oh.
Isn't it awesome? So,
Last week it was 9. Tonight it's 7:30.
well, it's because we were on antennas last week.
Yeah.
Oh, hams love their antennas.
What time? So what time? I gotta write. Should I let my son know now to come pick me up, or
Where do you live, Jeffrey?
down by the Holiday Inn?
Harmony Knowles.
Oh, Harmony Olive. Oh,
Yeah.
okay, you're off to find out what's the
Amateur station. If you remember when you were learning the phonetic alphabet and Q codes, that's all chapter 12. So it goes through basic operating procedures, all of the Morse code stuff that you're never actually going to use. Like, what does BK mean? What is like, I don't know. I don't know. What other?
like all the phonetic stuff, the ARs and.
Keywords,
Oh yeah, well the Q codes, of course, but
CQ, CQ.
yeah, how to call CQ correctly. So that's going to go through how to work that. 13. I want a textbook because I
Modulation and transmitters.
Modulation transmitters. So that's going to be a bit of a fun section. That's going to talk specifically about how radios go together, how an AM radio works is like block diagrams, so like where the crystal is, that sort of stuff. So that's going to be a fun one where you have to memorize all of the block diagram and know, you know, they'll be like, which component connects this one to this one in an FM transmitter? And there'll be hundreds of those questions. And then 14, finally we move on
If you have
to
a transmitter, you need a
Receiver.
Antenna.
everything, yeah.
yeah
Power.
receiver.
Can I have my
An
license already?
understandable Wi-Fi, I'd say.
That could, yeah.
And then, sorry, what is chapter 14?
Receivers.
Receivers. Oh, okay, yeah. So 14 is on to receivers and all of the different block components in that for AM, FM, single sideband. So transmission, receiving, and how to generally start working your setup. Which is good because 12 will also go into a lot of digital. And by a lot, I mean like a lot. They will talk to you in small paragraphs about every digital mode you could possibly want to work. Not enough that you actually understand what's going on in them, just enough to know that they exist. So.
Are they on the exam too now?
They are. Yeah, specifically APRS is on the exam and AX25 is on the advanced test in depth. But
Who uses it? Like,
APRS does.
hardly anyone's using packet anymore as such. APRS you use it, but it's all behind the scenes.
It is, but that's what I'm saying. So the advanced will go into more of the details of what's inside the packet and which parts of it you need.
Are you going to
But-
be the instructor for the advance?
Probably not. I probably need to get my advanced before I could do that, but yeah. I guess actually that's the next thing after we're done all this will be the advanced class if we don't do another basic before that. But
It'd be fun.
yeah.
It'd be fun.
The advanced, though, as far as I'm understanding so far, it wouldn't be a 1 week multiple chapter sort of thing. It would be 1 week, one chapter. We'd have to do a bunch of hands-on stuff. Because it's a lot more like you have to build this circuit, know what every part does, and the different calculations for each of the different components in it. So,
So it's better to have a year or two before you do that.